All right, so those are our definitions of acids and bases. So now let's come back to this issue of water and how water can act as an acid or a base. So if it can act as an acid or a base, it seems like it can react with itself to do some chemistry, and it can. So up here, you could have one water molecule acting as an acid, giving up its hydrogen ion to another water acting as a base, forming hydronium ion, and also forming hydroxide ion. So then you can ask the question, well, how much H2O is in a typical glass of water? How much, like the idea that I'm drinking hydroxide ions, how much hydronium ion and how much hydroxide ion are in this glass of water? How much H2O is in a glass of water? So that's the question. So here's the equation again. And we can think about how to calculate it. What do we really want to know in this question? What are we really asking? How much at an equilibrium situation, how much are products and how much reactants do you have? What can tell me about ratios of products and reactants at equilibrium? K. And how are some ways you can calculate Ks? They're different terms, but right, it's what is K? So we have the equilibrium constant. There are a couple different ways one might calculate K. You might be given concentrations at equilibrium, or you might be given information about delta G. So you can calculate Ks from delta G naughts. And this is an equation that you'll use pretty often. Delta G naught equals minus RT natural log of K. So if we want to know K, we need to find out what delta G naught is. What are ways to calculate delta Gs? So we've seen some of those. And I guess you're probably recognizing these already, temperature and our gas constant. So we can solve for K in terms of delta G. And how do we calculate that delta G? Well, there are a couple ways. So you can think about the delta Gs of formations. And we can think about one of my personal favorites, which is a relationship between delta H and T delta S. So you can think about your enthalpies and your entropies at a certain temperature. And you can calculate delta G, and from that you can get the equilibrium constant.